I'm recording this. Please feel free to stop me anytime you have a question. It's all good. I could go back and re-record. And on this video that I'm making in class live, I want to show you guys that it's not just about taking the information and just plugging it in, right? You got to take the information, think about what that information means, and then choose your best path, right? So I want you to copy down this first question. So on this question, they tell you that a line passes through the point 0, -7 and is perpendicular to this equation. So what information are they actually giving us? Well, they're giving us a point, which is a x1, y1, and they're also giving us indirectly, they're giving us a slope when they tell us that our line is perpendicular to this line. Parallel means same exact slope. Perpendicular means that this slope right here, our slope is going to be the opposite reciprocal of that slope. So what's our slope going to be? -5. That's our slope right there. Or you could say -5/1. So in reality, when we read this sentence, we have the information of a point, 0, -7, and a slope. So most of us would immediately say, I'm going to jump right into point slope form, which is y minus y1 equals m parentheses x minus x1, right? I mean, makes total sense. They gave us a point. They indirectly gave us a slope. Point slope form would be a great idea. But I would like you to just stop and think of what kind of point they actually gave us. Yeah, it's a coordinate. Yes, it's a point. And the slope. Okay, yeah. But what kind of point is this? If you take a moment and think about it, that location on the xy plane, 0, -1, 2, 3, 4, 5, 6, 7, that's that location right there, 0, -7. So not only is it any point, but it's actually the b value, -7. Does that make sense? Yay? I hope so. So they actually give us the slope and the y-intercept. So if you know your slope and your y-intercept, you might as well write it in slope-intercept form, y equals mx plus b. So what's our equation going to be? It's going to be exactly that. Y equals m, which we know is -5 because they indirectly gave us that slope, telling us that it's perpendicular to this given slope. So it's opposite reciprocal. That's why it's -5. And then plus b, they actually gave us the b because that location, that point, is more than a point. It's actually the b value, the y-intercept location. So that's -7. So this is our slope-intercept form equation, but they're asking for standard form, right? Standard form is ax plus by equals c. So you'd have to move this x value to the left side by simply adding 5x and adding 5x. So your standard form equation will be 5x plus y equals -7. There is your standard form equation, and that's what they want. They want the standard form equation of the line that passes through this point and is perpendicular to this one. Okay, so the beauty of math is that there's so many roads to the same place, right? It depends what road you want to take. So once again, they gave us a point. They gave us indirectly a slope. We could have jumped into point slope form. You know what? I'm going to do that. Like, we already have our answer. So if you understand that, you're good. But just to strengthen your mind, let's look at an alternate route. We could have said y minus y1 equals m parentheses x minus x1, and we could have plugged in our y1 value of -7 right there, our m value of -5 right there, and our x1 value of 0 right there. And then that's in point slope form, but they want it in standard form. So you don't want the parentheses. Well, technically, you don't even have parentheses because x minus 0 is just x. So you really just have -5 times x, which is just -5x. And you have the -7 that becomes +7. So you really have a y plus 7. So to get it in the standard form, you would move the x over here and the number over there. I'm going to start with the number by subtracting 7, rewriting this thing. That's going to be a y equals -5x minus 7. And then moving the x to the other side by adding 5x and adding 5x. So you're going to have 5x plus y equals -7. See, it's the same exact equation. It's just done a different way. So This explanation took a little bit longer. Why? Because I did the same question two different ways, right? I took the point and the slope and used point slope form, did it this way. But the first way was understanding that this point is more than a point. It's actually the b value. So they give you the m, they give you the b, plug it into y equals mx plus b, and then you could change it to standard. I love this question because there's different ways of doing it. And not only that, it gives us the opportunity to talk about all three different forms that we've done in this unit. Point slope form, slope intercept, and of course, changing them to standard. Has all three forms that we've talked about in this unit. Let's move on to another question. So on this question, it says a line has the slope 2/3 and the x-intercept of -9. It says write the equation in slope-intercept form. And everybody should know that slope-intercept form is y equals mx plus b. So you need two things to write a slope-intercept form equation. You need the m and the b. And you're thinking, well, they give us the slope and they give us an intercept. Hey, I'm ready to go. No, that's wrong, okay? The b value, if you remember correctly, is the y-intercept, not the x-intercept. And right here, they're telling you it's an x-intercept, okay? So if you wrote y equals 2/3 x minus 9, that's going to be totally wrong. Why? Because the b value is not your x-intercept. It's the y-intercept, okay? I wish this would have been a y-intercept. It'd be easy, but it's not. So what do they really give us here? They give us an m, and they don't give us a b. Okay, so we need those two things to be able to write it in slope-intercept form. We need a 2/3 for the m, and we don't know the b. If we could find the b, then we'd be able to write it. So again, they give us a slope. What else do they give us? What does this mean, the x-intercept of -9? We may have to sketch it to see the visual of what that means. The x-intercept, that would be your x-axis. X-intercept of -9 would mean that your line passes through the x-axis at -1, 2, 3, 4, 5, 6, 7, 8, 9. It passes right through that point. I don't know if this line is crossing like this, like that, maybe really steep. I don't know, right? But we do know that it passes through this point. So what are they really giving us? They're giving us a slope, that's our m value, and they're giving us a point, -9, 0. Okay, so they're giving us a point, -9, 0. So they're giving us a slope and they're giving us a point. We could write this equation in point slope form if we wanted to, okay? So let's actually do that. Let's write it in point slope form. You know what? I'm gonna put a squiggly line right here, and I'm gonna show my work in this bottom left corner, okay? Point slope form, that is y minus y1 equals m, parentheses x minus x1. And of course, when you use it, I recommend you leave blank spots like y minus blank spot equals blank spot, parentheses x minus blank spot. All right, now we could actually plug in our y1 value. And if you're thinking, wait, they don't give us a point. Yeah, they do. The x-intercept of -9 is the location -9, 0. So the y1, the y value is 0. So that's going to be right there in the y1 spot. So you're going to put a 0 right there. The m value is 2/3. They gave us the slope. That was easy. M is 2/3, put in 2/3. And the x1 value is the x value of that point that they give us, which is a -9. And of course, the minus minus changed to plus plus. So there's our point slope form equation, but they want it in slope intercept form. So we don't want point slope form. We want slope intercept, which means y by itself and no parentheses. And that's pretty easy because y take away 0 is exactly that, y. Y is by itself. All I need to do is distribute this fraction into those parentheses. So before I do that, let me zoom in to have some space. So we're going to distribute 2/3 times x. That's 2/3 x, and then 2/3 times 9. You could put the 9 over a 1 and multiply the top with the top and the bottom with the bottom. 2 times 9 is 18. So we have plus 18 up on top, and on the bottom, 3 times 1 is 3 down here. Okay, and we almost have it in slope-intercept form. All we have to do is reduce any fractions possible. 2/3 can't be reduced, but 18 divided by 3, that's actually the nice natural number 6. So we have y equals 2/3 x plus 6. And that is your answer to this problem. They asked for the slope-intercept form equation, and that's what we got. we found the equation in slope-intercept form. Now, that is because I chose to take the slope and this point and go with point-slope form. Like I said, in math, there's many roads to the same place. So you could have just stuck with slope-intercept form. You're like, I want to write it in slope-intercept form, so I'm going to just stick with slope-intercept form, okay? Now, if you're cool with the point-slope form, that's great. I'm going to explain it in a completely different way, just sticking with slope-intercept. So if I wanted to just stick with slope-intercept, again, you still have to identify that the x-intercept of -9 is really talking about the point -9, 0. That way you understand that you really do have that x value and that y value, okay? But if you didn't want to use point-slope form and you only wanted to use y equals mx plus b, you could plug in the y value of 0 right there. So you would have 0 equals, and then your m value of 2/3 right there. So you'd have 0 equals the m value of 2/3. And then it says times x. So you'd put times, and the x value you'd get from that point, -9. And then you still have the plus b, okay? So by us plugging in the m, the x, and the y into y equals mx plus b, we now have an equation that could be solved for b. And remember, if I have the m and I have the b, I'll be able to write it in y equals mx plus b form. So there's an alternate route. Multiplying the top with the top and the bottom with the bottom, you'd end up with -18/3 plus b equals 0. So -18/3, that's really a -6. So we really have the equation. I'm running out of space here. Let me write it up here. 0 equals -6 plus b. And then you would get b by itself by adding 6 and adding 6. So that would be b equals +6. 6 equals b, b equals +6. So now that you know that the b value is 6, we have the m that they gave us originally. We plugged in the x, the y, and the m to solve for b. Now we could write our equation in y equals mx plus b form, which would be the same exact answer as what we got down here. Y equals mx plus b. Y equals 2/3 x plus 6. So I did this 2 different ways just so you could pick the one that you feel more comfortable with and go with that. So one more time, just to reiterate, the first method that I used was I took the slope and I understood that this is really a point, -9, 0, and I used point-slope form. Plugged in my slope there and my point right there, x1, y1, and I distributed and changed it to slope-intercept because that's what they wanted. The other way is to not do point-slope form, take the slope, take the x and the y, and plug in the slope, the x and the y into this equation. That way you could have an equation that you could solve for b, right? You multiply these numbers together, you ultimately got a -6. 2/3 times -9, if you did it on the calculator, it would be a -6. That's exactly what we have. 0 equals -18/3, that's a -6. So 0 equals -6 plus b, add 6, b equals 6. So once we have the m and you have the b, you could write it in y equals mx plus b. That'd be y equals 2/3 x plus 6. That's exactly what we had the original way. So it's totally up to you, whichever way you like. Let's move on to the next one. So on this one, they give you some information and they want you to write your equation in slope-intercept form. What is that? Y equals mx plus b is slope-intercept form, okay? So a lot of us are going to make the mistake of saying, oh, that's easy. The answer is going to be y equals 2/3 x minus 7. Wrong, okay? Again, this whole lesson is about me giving you information and you thinking about the information before actually doing any math. So they give you a y-intercept of 2/3. The fraction is not your slope. This fraction right here is actually your b value. That's the y-intercept, right? And then they tell you your slope is -7. So what's your equation actually going to be? The correct equation will be y equals, what's my slope? -7 x, and then plus b, which happens to be plus 2/3. There's your correct slope-intercept form equation. Y equals -7x plus 2/3. I mean, you could technically put it over 1 if you want, but you don't have to. -7x plus 2/3. Any questions? Super easy, right? Ladies and gentlemen, here's another one that has many paths to the same place, right? It says a line has the y-intercept of 5 and passes through the point. So first we got to understand, what are they giving us? what are they giving us? They're giving us technically, what is a y-intercept? That's a b value, huh? They're giving us a b value of 5. If we had the m value, we could work with y equals mx plus b, but they don't even want the equation in y equals mx plus b. They want it in point slope form. So in order for us to write it in point slope form, obviously we need a slope, which we don't have, and we need a point. Do they give us a point? Yes, they do. The y-intercept of 5 is actually a point. It's actually a coordinate. Let's think about that. Maybe you need a visual here. Here's your x, here's your y. 1, 2, 3, 4, 5. We know that that's where the line will cross. That's what the y-intercept means. It's going to cross maybe like this, maybe like that, maybe really steep going down, who knows. But we do know that it passes through that location. And that location is an actual coordinate, which is 0, 5. So what are they giving us? What information do they give us? They're actually giving us 2 points. They're giving us the point 0, 5, and the first point that they gave us was -7, 12. Okay, so imagine -7, 12. It's up here somewhere. So from left to right, this is your first point. That's your second point. So what could we do with 2 points? We could find the slope using the slope formula. Yay? So we could actually use the slope formula to find our slope, right? And we need the slope regardless of what form they're asking us, slope intercept or point slope. We need the slope. So we're going to go with this formula. I always say start out with blank spots, the division and the blank spots, and then label your points. I want to call this first one x1, y1. That's the point that they gave us. And our second point, the y-intercept, which is actually the location 0, 5, I want to label it x2, y2. And when we plug it in, we're going to end up with 5 minus 12 over 0 minus -7. And that changes the plus plus. So what we really end up with is m equaling -7 over +7, which means that m equals -1. Are you with me? Now that we know our slope and now that we have a point, we could actually write it in the form that they want, point slope form. Okay, so point slope form is y minus y1 equals m parentheses x minus x1. Rewrite it with blank spots. That way you could easily plug in your values. The y1 value we see is 12, so we're going to put a 12 right there. The m value we see is -1, put a -1 right there. The x1 value is -7, put a -7 right in there. Change the minus minus to plus plus, and voila, we have our point slope form equation. That's what they wanted, that's what we have, that's what we type in, and we're good, okay? If you understand that, that's fantastic, all right? And you're done. However, for the sake of exercising our brains, I'm gonna show on an alternative path, all right? Let's say you wanted to use slope-intercept form, y equals mx plus b, and they give you a point and they also give you a b value, a y-intercept value. Instead of going with the slope formula, you could take what they give you here and plug in your x1 right there into the x spot, your y1 right there into the y spot, and you don't have an m to plug in here, but you do have a b to plug in there, and you'd be able to solve for m in this case. So once again, instead of y, you could plug in the y value that they gave you, which is 12. Then you have equals. The m value, we don't know, so I'm going to keep it as m, but I need to multiply it by x, so times, and I could get my x value from this point that they gave me, a -7. And then I still have the plus b, which, wait a minute, I still have the plus 5 because b is 5. So I take that 5, plug it into b, there's a 5. And what we have now is an equation with one single variable, in this case m, that I could actually solve for, right? So when I actually solve this thing, what is m times -7? That's -7m. Bring down the +5, the equal sign, and the 12. To get m by itself, you're going to get rid of the +5 by doing the opposite, -5. And what you do to one side, do to the other. You're going to end up with 7 equals -7m. Get rid of the multiplication of -7 in front of the m by dividing by -7, dividing by -7. You're going to end up with -1 equals m, m equals -1. And now that you know your point that they gave you and the slope that you just found out, you're going to be able to plug it into point slope form, which is y minus y1, that's 12, equals m, which you just found, -1, equal parenthesis x minus x1, which is -7, and you'd end up with the same exact point slope form equation. So I just did it a different way completely. So again, the explanation is long. It's long because I did it in two different forms. It's like if I did the same problem twice. The first method was understanding that this is a point and that's a point, and I could find the slope between my 2 points. And once I have my slope and my point, I could write it in point slope form. The other way was to stick with y equals mx plus b, plug in the x, plug in the y, plug in the b, and you solve for m. And then once you have the m and the point, then you could write it in point slope form, okay? Do you have to do it in both forms? Heck no, right? But I'm explaining it both ways. It's good for you to understand both ways. Let's move on. So on this problem, it says a line does not cross the x-axis. That's interesting. What the heck does that look like? And it has a y-intercept of 2. Write the equation in any form. So they don't give us a slope. They don't give us a point. They give us a y-intercept, right? They give us a b value. The b value is 2. But they don't give us a slope. They give us some other information, that it does not cross the x-axis. So we might need to sketch something to get a visual to understand this better. Here's our x, here's our y. We know one thing for sure. This line passes through where? 2 on the y. The y-intercept of 2, okay? So it's going to cross right through there. I know that it passes right through there. It might be going down, might be going up, but then again, it says it does not cross the x-axis. So it can't be going down because that would cross the x-axis. It can't be going up because then that would cross the x-axis over here. So if it doesn't cross the x-axis, what does it mean? That it's totally flat. So here's a visual, totally flat. It's parallel to the x-axis, totally flat. So we have a perfectly horizontal line that crosses the y-axis at 2. And I hope we remember this from back when we graphed lines. Whenever you have a horizontal line and it crosses the y-axis at 2, that equation is y equals 2. Okay? Whenever it's a horizontal line and it crosses the y-axis, it's going to cross the y-axis if it's horizontal. Your equation is going to be y equals that value of where it crosses the y-axis. And likewise, let's say I would have had a vertical line, okay? Like this is not even part of the problem, but let's say I had a vertical line at 1, 2, 3, 4, 5. Let's say there's a vertical line crossing the x-axis at 5 right there. Then that blue line would be the equation x equals positive 5, okay? So vertical lines have x equals that number. Horizontal lines have y equals that number. That's something we learned in the past, something very important that we need to remember today and in the future, okay? So again, whenever you see a horizontal line, perfectly flat, that doesn't cross the x-axis, that's going to be y equals that value of 2. If it would have been up here at 5, it would have been y equals 5. If it would have been down here at -1, it would have been y equals -1. Anytime you have a vertical line, it's going to be x equals that value. Make sense? Okay, so this one, we didn't really have to do any math. We just had to understand the information they give us. Let's move on. This reads, a line that has an undefined slope, or a line has an undefined slope and passes through the point -13, 6. So what information do they give you? They give you a point, an x1, y1, and they technically give you a slope that's undefined, right? So you might be thinking, oh, point slope form. However, what does an undefined slope look like? You can't define it, right? It's not really a fraction. It's an undefined value. So if we don't understand how to do it algebraically, we should think about it visually. What does a undefined slope look like? That would be a line that's so steep that it's perfectly vertical, up and down. right? Kind of like the wall. The wall has an undefined slope, okay? So once again, an undefined slope is a line that's going straight up and down, not rising and running. It's going straight up and down, an undefined slope. And we do know that it passes through the location negative 13 comma 6. So that would be negative 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That's ugly. I apologize, but you get the idea. It crosses, well, actually not even at negative 13, 0. It crosses at negative 13, 6. So 1, 2, 3, 4, 5, 6. So that would be the location right here. And since it's an undefined slope, we know that it has to be going perfectly vertical up and down through this location. So that would be this vertical line. And again, if we have a vertical line, what's the equation going to be? X equals or Y equals? X equals, and in this case, negative 13 is the X value. So there's your answer for this problem. X equals negative 13. Again, if you have a vertical line, it's going to be X equals. If you have a horizontal line, it's going to be Y equals. Like if I had a line crossing the Y axis at 6, that would be Y equals 6. Right here, it's a vertical line because undefined slope is up and down. That crosses the X axis at negative 13. That's X equals negative 13. Last question. A line is parallel to the Y axis and passes through the point negative 2, 7. Write the equation in any form. I want to begin by doing a sketch. Where is negative 2, positive 1, 2, 3, 4, 5, 6, 7? It's going to be up here. That's where my line passes through. It says passes through the point negative 2, 7. It might be going down, might be going up, might be flat, might be vertical. Who knows? Depends on the slope. They don't give us a slope, but they do tell us that a line is parallel to the y-axis. So this one is the x-axis, this one's a y-axis. What does it mean to be parallel? That it's never going to cross, right? It's never going to intersect, has the same slope. So what slope does this y-axis actually have? It's a vertical line. That means that this line that passes through the point negative 2, 7 is also perfectly vertical, right? So we know that vertical lines are the equation what? X equals or Y equals? X equals, and in this case what? X equals what? Negative 2. Because we know that the X value of that point that it passes through is negative 2. And if it's vertical, it's going to cross the X axis at negative 2. And that's about it, guys.